Cool. Yeah, looks like I'm a malicious actor for the No Shoes Network. Hopefully the network is BFT. 2/3. Cool. Yeah. Hey everyone. So my name is Kevin Chen, and I'm the founder of Iota Evangelist Network, and I'm also a co-organizer with Dan for the Iota meetup group here in New York. So just a quick show of hands. Who has been to an Iota meetup before? Wow, less than half. So we have a lot of new people here. So who's vaguely familiar with Iota? All right. So yeah, yeah, some familiarity, but yeah. So for this presentation, I'll definitely go a little bit also to the basics as well. And just a quick description of myself. I created the Iota Evangelist Network. And this network is a group of dedicated Iota enthusiasts, developers, and professionals around the world who's looking to evangelize, trying to spread the awareness and adoption of Iota technology around the world. So yeah, without further ado, let's begin. This way? I was holding it the wrong way, so it's pressing the wrong arrow. Yeah, so yeah, for the structure of this presentation, I want to discuss a little bit about the two parts. The first one is kind of giving an overview of what Iota is, a little bit of like how it works. But I also wanted to emphasize a little bit about the second part, about the need of developing a global ecosystem. And this is kind of something that's kind of discussed with Andre, of actually trying to build more of interoperable like technology infrastructure. But I also wanted to discuss that there is also a need to develop interoperable and co-create new different types of ecosystem where you can have different businesses, no matter which type of domain industry that they're in, to actually work together and to share data with each other, and actually try to find ways to actually break down the barriers of actually trying to hide like the data, and actually have them to kind of have the incentives for them to share data rather than for them to hold it and use that as the way for them to have value. So a quick overview for Iota is that Iota is a DLT for the Internet of Everything, and has some features that includes scalability, low fees, quantum resistance, and some of which that I'll get into here. But before I get more into like why Iota and how it works, I kind of wanted to go and also give a little bit of a background as well. So data is the new oil. So that means that data, especially valuable data, will become valuable assets for business-driven purposes, and ultimately with the hopes that these data could become standardized, then they can also become commoditized as well, just like how oil it is today. So what's driving this data is a new oil trend, and then there's 2 or 3 different factors. So the first one is that there used to be data silos where all the different like businesses are just kind of hoarding all the different data in their like on-prem data centers, and then they're just using the data for themselves, even whether they actually use the data or not, but they're just like holding onto it. And then there's a more recent development, which is called the cloud, where now there's data is becoming more like open, and it's become more co-located into different cloud providers such as Amazon, Google, Azure, and others. But nevertheless, that there is still owned by like private entities. But I think the big transformation, and the one I'm most excited about, is the rise of Internet of Things. So who here is familiar with IoT? So yeah, so IoT is more of like an internet of, so like today's internet is just like internet of computers, mobile phones, servers, data centers, etc. But I think that tomorrow's IoT has a more diversity of different types of things, widgets, gadgets, appliances, devices, machines that could then become connected and onto the internet today. And I think the part that really excites me the most about the IoT is how like you have all these different devices and sensors are able to gather all these different types of physical phenomenon around this world, and you will have the understanding and the awareness of all the like the phenomenon that's going on. And I think this could really help us like understand, like if we have less blind spots of the different things that's going on around the world, I think, and we have this information, I think that this can really help us make a lot better decisions. But we're still not quite at that utopia, so to say, because there are still some kind of obstacles that are preventing IoT from becoming completely ubiquitous. And one of the big ones is that there's still a lack of trust in the, okay. So there's still kind of a lack of trust in the data, especially about how the data is being originated, whether like the data is actually coming from the sources that you think it's supposed to be coming from, or could it become like be from an imposter, that someone is like faking the ID of a certain device and is giving you bad or faulty data. The second one is still a lot of the network connectivities, which is still need for real-time transactions. And there's also some kind of interesting developments, including the rise of like 5G networks, where they are the throughput has been increasing from 4G is kind of like 100 megabits per second to 1 gigabits, and then 5Gs will be at least 10 times faster than that. And then the third one is, oops, spoilers. Yeah, and then third one is like how to actually develop business models around like trust in data and actually the connectivity. And that includes having more smarter, more intelligent business models, as well as increasing use of automation. And I think one of the big values of automation is that even though that there's a rise of big data, of course, it will not be possible for like just humans to consume all that data, since right now we're already overloaded with the data coming from like the internet, from the web and so forth. And then we'll get even more overwhelmed if we're trying to ingest like raw data from like devices themselves. So there would be a value for automations and robots to kind of pre-process this information, and then to kind of curate this data, and then to make it more digestible for ultimately for the human users to view, and with the hopes that they can make better decisions. So how does blockchain come into play here? So blockchain may really help with the trust in the data by using the primary example of blockchain, which is a cryptocurrency. You need to use the private keys in order to like create a digital signature and then sign and make it put into transaction. And then you have like other parties, like in Bitcoin's case, like the miners, who then would have to like authenticate you, like making sure that your digital signature is real. And then before they actually put your transaction to the block, and then it goes through the proof of work process, and then actually getting that block actual validated, confirmed onto the blockchain, hence your own transaction. So it's possible that we can do similar things with, instead of using Bitcoins or cryptocurrencies, that you can actually use like IDs of different things or identities, and then use the like the cryptographic schemas that's already been built on Bitcoin blockchain to do the same type of authentication. However, and also the reason why we're currently here is that there's also some challenges in the blockchain space, and then primarily with the issues of like the scalability problem and the high fees, because Bitcoin right now is kind of built to be kind of fixed at a certain block interval. like a block interval size, which is about 10-15 minutes per block, and it can only fit about 1 megabytes of transactions onto it. So on average, it's only able to process or confirm 3 to 7 transactions per second right now. And then this makes it, there's a high variability of the like the fees that's associated with Bitcoin, for example. And then that's mainly because that you cannot like really like make the block bigger unless if you like fork it and then try to make it block bigger, which is what actually happened a few times. And because of that, if there's more demand for this like fixed supply of block space, like the space where you can put the transactions, then of course the miners will then have to charge like higher transaction fees, and they will of course pick the transactions to put into their blocks that gives them the highest amount of fees, because miners are incentivized by financial returns for their like electricity and energy for them to actually run the miners in the first place. So this is where this is where there's this rise of these new distinctions as addressed by the two previous speakers. There's a rise of a new type of like categories of blockchains, which is called DAGs, directed acyclic graph, and Iota is one of them as well. And the key feature of DAGs is that they want to resolve these scalability issues that's been plaguing blockchain, so that especially in Iota's circumstance, that is able to make distributed ledger technology to be more accessible to use cases such as IoT. So just a little bit of quick run through of how the Iota transaction works. It's like a specific type of DAG where there's, so you have these, so these are first actually transactions. There's no blocks in Iota. So these are individual transactions. And so these are confirmed transactions right here. These are unconfirmed transactions, but they're still on they're recently attached onto the Tango. So just a real quick difference, the Tango is the name of the DLT, and Iota is the name of the like the organization of Iota as well as the token. So there's that small distinction. So how the DAG works here is that so let's say that we have like a new incoming transactions. I made a transactions to, let's say you, Brad. So let's say that this is this transaction right here. So in the protocol, whenever I make a previous transaction, the transaction actually validates two previous transactions right here. And then the validation process includes things like checking to make sure that the digital signature of the transaction works. Also make sure that it's not a double spend by transversing through the Tango. And then the last part is also a proof of work, but this proof of work is actually not part of the consensus. Rather, it's part of a way to prevent too much spam. It's kind of like the something called a hash cache, which is like a proof of work where when I send like a email to you, that the server has to do a little bit of proof of work to get it through to my receiver. And this is a way to prevent spams from sending like thousands of transactions to a given inbox, and then like trying to spam the like that inbox, and it makes it harder because for each of these emails you have to do a little bit of work. And so this is kind of the same thing here on the Tango as well. So after each transaction goes through like all three of those steps, then this becomes like a purple and becomes an unconfirmed transaction. So how does it get confirmed? So how it gets confirmed is until enough future transactions directly or indirectly validate our transaction right there. And if it passes this certain threshold, then this will be marked as confirmed. And how does this, and then who sets this thresholds? I, I think long term, it will ultimately be decided by the users and the receivers themselves, that they can determine based on how important this transaction is, how much future transaction will have to validate the like directly or indirectly their transaction. Although I think in the future there might be some kind of standards of what type of like the number or the weights of the transactions that's needed. So this is just like a quick like a graph about how the Tango works. And I mean, there's a lot more details to this, but I think this is a good enough like overview to just kind of explain how it works. And one of the big key here is that you see in this validation consensus process, it's driven by all the transactors. So transactors validates previous transactions, and then future transactions validate that transaction. So what this means is that there's only one user group in Iota, and there's no minors. And because the minors are not needed, because the validation process is inherent to the transaction process itself. So, so one of the big benefits here is because since there's no minors, there's no need for mining fees. And hence there's no fees on the Iota transaction. And this makes it very, very useful for doing things like doing microtransactions or even doing batches of data transactions as well, because you can send a bunch of mini transactions without having to worry about having to pay underlying fees in the protocol. And this is one of the key features of what makes Iota pretty relevant to IoT, is because of the likelihood of all these different types of devices are able to do like microservices or resource sharings that might involve like nano transactions with their counterparties. So there's a lot of different opportunities here. How am I doing on time? 5 more minutes. Okay, so I'll just run through some of these use cases, since there's actually a lot. But I think one of the big themes is that even though that Iota, DLT, and even IoT, they are like horizontal technologies or general purpose technologies. In short, is that they can transcend various different types of domains. Domains includes like mobility, smart cities, supply chain, manufacturing, and so forth. And I think in the future, I think we'll see a lot of these different like domains actually kind of blurring with each other, and it's kind of hard to actually kind of categorize these different like domains like distinctly, because these technologies kind of traverse through each other. There's a lot of kind of co-creation, interoperability that's going on with these types of domains, and that might be kind of an interesting node, especially like in those in the financial industry that are like for example like investment banking, that they have like cover like specific like industry groups like industrials or healthcare or FIG, that there might be a likelihood that they may need to interact more with their other industry groups as well, or maybe even combine to join new ones, and so forth. So one of the big ones, I'll just go through real quickly, is the rise of applications in the connected vehicle space. So the connected autonomous vehicles, and that could be the one of the most interesting, sophisticated, complex IoT device that's out there. You can say because in order for it to drive autonomously and carrying passengers while minimizing any risk of like accidents, you need to have very sophisticated types of devices, sensors, lidars, and then maybe even more types of intelligence and also connectivity to the environment, smart cities, in order to make sure that like the passenger, the client, not only is absolutely safe in all circumstances, but it's also having this very enjoyable experience as well. So one of the potential use cases is that connected vehicles will also become very digitalized, and there will be some kind of a digital representation of these vehicles called digital twins. And the digital twins is just like what the vehicle is, what it does, but more represented in digital form. So some of the examples could be like having this car ID itself, like a VIN number, but it can also be different specific IDs as well. For example, like the different parts, like they can all have IDs. And what's useful is that I can go to this one, which is a use case, which is a UBI, which is usage-based insurance, is that instead, like for example, currently car insurance is based on for different people. And so each one of us have car insurance. So if, for example, if I drive really poorly, then my rates will go up. But let's say that in the future that you have more of these autonomous vehicles that basically drives by themselves. So there's right now an exploration of a new types of insurance paradigm that instead of the insurance being mapped to like individual people, that these insurance could be mapped onto specific cars themselves. And how would insurance company kind of determine what's the premium for, like if they're basing it on a specific vehicle, instead of getting like human information like social security, age, like your grade of your report card, you can get something like all the information from the car. And that includes odometer readings, telematics, when it went to the maintenance, how many passengers it drives. And all of this information comes from the cars themselves. And in order for the insurance companies to actually like understands was comfortable with the information it's getting that's actually coming from this actual car and not from like an imposter, that's where like a DLT would really come into play because of the authenticity and the identity of putting the different like the vehicle ID itself or the vehicle parts, and then create a digital signature, given that this vehicle has its own private ID, private key that it keeps, and then creates a digital signature, and then the insurance companies could then validate it and then ensure that these streams of data, telematics data, is actually coming from the car itself. So let me see. Another useful, interesting use cases are more of like smart cities, where right now some of the recent developments is that Iota is doing a, just like real quick marketing. Iota is doing, just working with the city of Taipei, Taiwan, as a way to create a more of a citizen-centric ID. So this is more of a like an identity of human users here. And but another use case that Iota is also doing is the creation of a data marketplace where you have all these different devices, and so they're like data originators, and they get these different data, and then they can actually have these marketplaces to sell these data to third-party potential buyers. So in the previous, for the previous use case with the UBI, so you have two parties, the cars and the insurance companies themselves. But then the cars could then sell these data to the data marketplace to users, to buyers that think that these type of telematics data might be useful. And one of the information could be like the actual, like the smart cities themselves, since maybe some of the sensors that the car could collect are for like road conditions, since these cars have like cameras right here, and then these cars that can then collect these like images or even videos, and then send it to the smart cities, and then the cities can then determine which roads that they need to fix, or which road needs better maintenance by the data that they've collected. So that is a really major use case that Iota is doing, and recently today they've actually announced it to be open source, and right now they've partnered up with all these different participants, these organizations, to be part of the marketplace during the trial. But right now they've also now released the code, so anyone could produce that has like sensors could then plug into the marketplace, and then maybe find and be part of the data exchange. Even though right now it's a proof of concept, but hopefully that this could be used in more commercial purposes down the road. So, so just finally, Iota is run by Iota Foundation and is a group of, it's based in Berlin, Germany, and has a team of at least 90 people around the world, and they're all actively trying to develop, continue to do R&D of this technology, but also trying to educate and also research and to standardize this technology as well in order to reach the next level of adoption. Yeah, so here's my information, here's my details, and here's more information about Iota. Thanks.